Hey guys, this is Mrs. Harmon, and this is Algebra 1 Section 1.3's presentation. Our verse for this chapter is Isaiah 55:9, which says, "As the heavens are higher than the earth, so are my ways higher than your ways, and my thoughts higher than your thoughts." We know that God created this world and everything in it, including the rules of math. And while we have come to understand a lot about math, there are still plenty of things yet to be discovered, and I hope you discover some new things this year in algebra. Our objective for today is that you, the student, will use the properties of addition on integers and rational numbers. So let's take a look at addition. In addition, the numbers being added are called the addends. And the answer to an addition problem is called the sum. So in the addition problem, 3 plus 4, for example, let me back up here. In the addition problem 3 plus 4, 3 and 4 are our addends. And our sum is 7. Now, when you're adding two addends or more addends with the same sign, we have some things to remember. We want to add the absolute value of the addends. Remember, absolute value is just how far away a number is from 0 on the number line. And then we're going to give the sum the sign of the two addends. Let's take a look at examples. 3 plus 2, well, these both have an absolute value of 3 and 2. So when we add the absolute value of 3 and 2, we get 5. And both of our addends are positive, so our final answer is positive. Now, we don't have to write the positive symbol. It's implied unless we state otherwise. -1 plus -3, well, the first thing we're going to do is take the absolute value. And the absolute value of -1 and the absolute value of -3, well, that's just 1 and 3. So we're going to add these both, and that gives us 4. When it comes to the sign, both of our numbers have negative signs, so our final answer is also negative. When you have different signs on addends, one positive and one negative, you're going to subtract the smaller absolute value from the larger absolute value. You're combining a positive and negative number. And you'll give the difference the sign of the addend with the larger absolute value. Let's take a look at what that looks like. So we have 3 plus -2. First, we're going to subtract the smaller absolute value from the larger. The absolute value of 3 is 3, and the absolute value of -2 is 2. So we're going to subtract their absolute values. And our sum, our answer, gets the sign of the larger digit. Well, 3 is larger than 2, which is a positive number, so our final answer will be +1. Again, we don't have to write the positive sign. It is implied. All right, let's take a look at this problem. Pause the presentation, if you will, and see if you can do this one on your own. If you came up with -2, nice job. If you're not sure how we got there, we subtracted the smaller value, the absolute value of the smaller value from the larger one, so that was 7 minus 5, and then our sum gets the sign of the larger digit, which was the 7. Try these examples on your own. -4, 8 plus -3 is 5, and 4 plus -10, -6. If you want to do these on the number line, remember that negative numbers move us left on the negative line. Negative numbers move us left, and positive numbers move us to the right. So if we take a look at this first problem, for example, let's put some digits on here. 5 here, and 1, 2, 3, 4, 5, and -5 here. Okay, for these, I'm starting at, like example A, I'm starting at -1. That's right here on the number line. And I'm going to the left 3. 1, 2, 3. And that's how we ended up at that -4. For the second problem, I'm starting at 8. At a spot here. And I'm moving to the left 3. That negative sign tells us left. 1, 2, 3, and landed at 5, which is what our answer was. And for our final problem, I'm starting at 4, which is right here, positive 4, and I'm moving left 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that lands me at -6. So for some of you, you may like the absolute value method, and for others of you, you may prefer a number line. Either way can help you with solving these problems. Let's take a look at another definition and talk about some properties of addition. A mathematical property or identity is an equation or statement that is true for any value of the variable. So these are true no matter what numbers we put with them. Now, what do people call their drive to work? Let's see if that gives us a hint. In our properties of addition. They call it a commute or their commute. The commutative property is if you add two numbers together in different orders, the sum is the same. So going back to this picture and our commute, our drive to work, and our drive home is going to be the same, no matter which order we add them in. What this looks like in math terms is this. A plus B is the same as B plus A. Putting some numbers with it, 3 plus 2 is the same as 2 plus 3. We can put our addends in any order, and the sum is still the same. The next property might help you, this picture might help you. 3 friends associate or get together, and that might help us think of the associative property. If we group numbers together differently when adding, the sum is still the same. So A plus B plus C is the same as A plus B plus C. We put numbers with it. 2 plus 3 plus 1 is the same as 2 plus 3 plus 1. No matter how we group those numbers, associate those numbers, the sum is the same. The additive inverse property states that the sum of any number and its additive inverse, or its opposite, is 0. So A plus negative A is 0. 3 plus negative 3 is 0. Again, this is an identity because, or property, because we can use it with any digits and it's always true. The additive identity property says that the sum of any number and 0 is that number. A plus 0 is the same as 0 plus A, and it's always A. If we put numbers in there, you guys already know that 3 plus 0 is the same as 0 plus 3. That's the commutative property there. And that it's always going to be whatever addend we started with. In this case, 3. Anything plus 0 is always itself. Let's take a look at some examples. We've got some positive and negative integers that we need to add here. See if you can do this on your own. Let's rewrite this first with our positive numbers all together and our negative numbers all together. Positive 5 and positive 4 gives us a positive 9. And when we add all of our negative numbers together, those can be simplified to negative 17. We now got a positive 9 and a negative 17, which leads us to negative 8. If you're using the absolute value, you're going to take the absolute value of the larger number, subtract the absolute value of the smaller number, so 17 minus 9, and then your sum gets the sign of the bigger number. Well, the bigger number was 17, so that's what our digit gets the sign of. If you're using the number line, you're starting on number 9, and you're moving left past 0 all the way down to negative 8. Here's another example to try on your own. Pause this video and see if you can work it out. We're going to group our negative numbers together here. Now, we said 8 and negative 8 is 0. That was one of our properties of addition, so they canceled each other out, which left us with negative 3 and 15. And thanks to our properties, we know that anything plus 0 is itself. So that answer is 12. So think about what we did today. Did we add integers and rational numbers? Yes, we did. Now, we didn't do any rational numbers specifically that had different denominators. That would be something like 3 over 4 plus 7 over 8. Well, integers are a type of rational number. We did not do these specifically. So just a quick reminder about these. If you're adding rational numbers that have a different denominator, remember you've got to make them a common denominator first. And when I look at these two numbers, I know that these are both factors of 8. Well, this one's already in 8, so I can leave it. In order to change this one to 8, I'm going to have to multiply the top and bottom by 2. That leads me to 6/8. Now I can add 6/8 plus 7/8 and get 13/8. We did not practice any of those today, but just a quick reminder, when you are adding or subtracting fractions or rational numbers with different denominators, don't forget they need to be the same.